Hello, I will be discussing in this video solution of ordinary differential equations, and we will be discussing yung Euler method. Yung method, ito yung spelling ng Euler. Mathematician siya, sikat na mathematician. Euler, apelyido. So, yung differential equation naman, of course, there is a derivative, okay? We know that derivative of a function is the slope equation. Now, if we are going to locate a particular point, let us say at this point on the curve, and if we draw a tangent line, the slope at this point is can be determined by the first derivative of the function, and then halimbawa ito, let us say this is um, x equals to 1, we just substitute 1 into the derivative and we get the slope. Okay, so alam mo naman that the derivative is dy dx. Kumbaga sa figure, it is the ratio between the rise and the run. O kaya yung opposite side and the adjacent side. Yun ang yung ratio niya, ganyan yan, dy dx. So any line here, halimbawa, pag meron kang gustong malaman na, halimbawa itong distance na to, at sabihin natin this is A, okay? If we want to know this vertical distance here, knowing the slope of this line is this, vertical distance is equal to A times dy dx. Paano nangyari yan? We know that the slope of this is dy dx. Okay? So if we take the proportionality of triangle, that is dy dx is equal to v over a. Therefore, if we cross multiply v is equal to a times dy dx, or yung vertical distance is equal to the distance a, or the horizontal distance multiplied by the slope of the line. So kung meron kang line, alam mo yung slope niya, so just multiply this distance, slope times this, you get vertical distance. Okay? So ganun lang. Kasi this is the basis of Euler method. Yung vertical distance can be determined by multiplying the slope or the derivative times the horizontal distance. So tandaan nyo, to get the vertical distance, all you have to do is to multiply the slope and the horizontal distance. So let us now study the Euler method. Paano ba yung Euler method? By the way, as an example, yung halimbawa, this is the curve, let us determine the slope at x equals to 1. So ano daw yung slope of a tangent line at x equals to 1? So nasan yung 1? So if we look at 1, nandito siya. This is 1. Okay? So we project this up, dito siya. So anong point itong distance na to? From here up to here, anong distance yan? Okay? Of course, makukuha natin yan by substituting values into the equation. Kasi ito yung y is equal to x squared plus 2. Ganun lang naman eh. you know the value of x, you get the y. So just substitute x equals 1 squared plus 2 and y of course is equal to 3. So ibig sabihin, when x is 1, y is, this is 2, of course this is now 3. Nandyan sa yung point niya, okay? Yung intersection. Now, what we're going to determine now is the slope at the slope at x equals to 1 or y equals to 3. Okay, so dyan. So dito natin nanapin. At x equals to 1, what is the slope? Kasi automatic naman makukuha mo yung y by substituting it here. So pwede naman sabihin, what is the slope at x equals to 1? Kasi yung mga problem na yan. So the slope at x equals to 1 of the, yun, yung anong curve ang yung given. Okay, so dito yung slope natin, drawing natin. Okay, tangent line. Okay, ano daw yung slope dito? So, first, yung ordinary solution ay we solve this. This is dy dx is equal to 2x, diba? This is not the slope equation. Ito na yung tinatawag natin na slope equation. Now, if we want to determine the slope at any point along this curve, or this is a parabola, let's substitute the value of x. Ano ba? What is the slope at x equals to 1? So, dy dx, or this is equal to the slope at x equals to 1 is equal to 2 times 1, which is equal to 2. So, ito lang. At x equals to 1, this is 2 times 1. Therefore, the slope is 2. Paano in-interpret yung slope na 2? Yung vertical mo is 2. Yung horizontal mo, of course, this is 2 over 1, di ba? So, yung slope mo ay 2, 1. So, mataas siya. 1 equals 2. Alam ba, meron kang slope. Alam ba, yung slope mo ay 2/3. Ibig sabihin yan, 2 vertical, 1, 2, 3 horizontal. Yan ang line mo. So, ma-determine yung inclination ng line pag alam mo yung slope. This is 2, this is 3. Okay, so that's how we interpret derivative. So, ito naman, yan yung slope. Okay, so let us discuss na yung Euler method. Napakadali na ng Euler method. Ito, mag-part 2 ako. Kasi yung differential equation, may mga initial problem, initial condition niya. What is x? Ano ba? If you are dealing with velocity, ano ba? At the start, velocity and time. Then you get the distance. Parang gano'n siya. Okay? So, that's it. The time is 0, the distance is 0, or the velocity is 0. That is the initial condition. And then, of course, you have this relationship v equals to distance over time, so on. So, it is dependent on the condition of the problem. So, you make an equation, then yung initial condition na at the rest, the car start the race when velocity is 0, distance is 0, time is 0. And that is the yung tinatawag na initial condition. So, pwede mo naman sabihin, yung velocity is constant, yung distance sa time, yun ang variable. So, what is the distance traveled when time is 5 seconds, when time is 2 hours? Parang ganon. Initially, the time, when the car starts at 0, when time is 0, it means you see that start at at rest, then it travels at a constant speed of then you'll be asked what is the distance traveled the end of 1 hour, parang ganun. So yun ang problem. Depende sa condition of a problem. So, yan, pwede naman tayo gumawa ng problem dito. Let us see. Uh, what is the value of y when x equals to dito tayo sa 2. Alam na natin yung 1, di ba? So, yan. Of the differential equation dy dx is equal to x. Parang ganyan. Okay? So, yun ang problem. Originally, ito naman yung equation natin. Okay? Uh, we are asked to find the value of uh, y at that point, given the differential equation. Kasi nga, ito hindi binibigay sa inyo na sa sample ko, nandito na yung solution. Pero originally, this is a differential equation and then you solve backward to determine the condition. So yung condition natin when x is 0, y is equal to 0. So meron naman ganito yung mga initial condition. Pag sinabing y dito. Yung may mali yung natin. When x is 0 daw, y is 2, di ba? We substitute value here. When x is 0, y equals to 2. Ito. Di ba? When x is 0, y is 2. Tama naman. If we substitute 0 here, y equals to 2. Okay. So your initial condition, when x is 0, y is equal to 2. Now, in other problems, ganito yung representation ng initial. When x is 0, y is equal to 2. Okay? Ito yung isang form, ito yung ibig sabihin niya. Baka makakuha tayo ng mga initial value problem. So, binibigay with y0 is equal to 2. Kasi ito yung x, diba yung function of x is equal to that, which means this is y is equal to this. Yung fx, y equals to function of x. Means to say, that if you substitute values here, makukuha mo yung value ng y. Kasi ito, this is equal to y. Okay, so yan ang mga interpret natin ng mga equations. So, ano tayo? So, pinapasolve sa atin yung value ng y0. Wala pa tayo. When x is equals to 2. So, ito yung pinapahanap. Okay? When x equals to 2. Yan. What is the value of y when x equals to 2? So, yung pinapahanap sa atin, kumbaga dito, x is 2, what is the value of y? So, ito yung ibang form. Ito naman yung isang y, what is y when x equals to 2? So, ibig sabihin niyan, of course, we know that sa dito, 6 na yan yung value, 6 ba yan? Parang 6. Now, ordinarily, yung solution natin ganito. So, from here, dapat may balik natin dito. So, paano ginagawa natin? Dy is equals 2x dx. Iso-solve natin. Okay, yung equation niya. Sa ordinary solution to. Of course, we integrate both sides. This is y. This is 2x squared over 2 plus c. Okay, so y is equal to x squared plus c. Now, yung initial condition when that is when x is 0, y is 2. So, this is 2, this is 0 plus c. C therefore is equal to 2. Therefore, yung solution niya, okay, yung particular solution, yung original equation which is equal to dito tayo. Dito na nga. Y is equal to x squared plus 2. O, di ba? Ito yung original na equation niya. Nakuha natin yung C na which is equal to 2. Ito yung ordinary method. Now, the problem is, yung kung bibigyan ka na ng malalang problem, alam mo, hindi pa ito malala. Alam mo, dy dx is equal to negative 4 y over x plus x squared. Yan. So, paano mo isosolve yan? Now, if we cross multiply, we have, ano yan, x dy is equal to negative 4y, hindi pwede pa, yung solution natin dito, sa ordinary solution, ganito yan. We cross multiply dx, so we have dy is equal to negative 4y over x dx plus x squared dx. Okay? Ang problema natin yung itong dito kasi nga may halong y sa dx. Paano mo yan mapupunta dito sa dy? Ang hirap niyan. Na kahit anong manipulasyon mo, hindi yan pupunta dyan, di ba? So, meron tayong solution yan, yung solution na yung integrating factor y e integral of p dx is equals to q e integral of p dx plus c. Okay, so yan. Kung natatandaan nyo, ito yung solution niya. Okay, so i-discuss na natin yung principle ng Euler method. Then later on na lang yung sample problem ng Euler method na differential equation. So, erase muna tayo, okay? So, this is just an introduction to Euler method para maintindihan nyo yung solution. Kasi yung solution niya, masyadong napakadali. Very, very simple lang. Parang kahit high school matututo mag-solve ng differential equation using Euler method. Kasi nga yung gamit lang yung algebra lang. Arithmetic lang yata yung gamit. So, ganito yan. Initially, alam mo, if we drew a tangent line here, parang ano ba, ito yung initial condition natin, okay? So, x is 0.5 ito, okay? Ito yung x, yung kanina, yung when x equals to 0, y is equal to 2. Ito yung initial condition. Okay, yung sabi ko yung sample ko na, when the car start at rest, so the time is 0, the distance is 0, the velocity is 0. Okay, so parang ganun yung mga initial condition. So, meron tayong alam dapat na condition sa problem natin. So, initial condition natin dito is x is 0, and then y, or initially, this is y. Ito yung initial. X is 0, this is y, dito. Now, ano yung slope dito? This is a function of xo and yo. Ibig sabihin na, kung ano yung equation mo, yung first derivative, i-substitute mo lang yung point dyan, makukuha mo na yung slope. Diba? Dito yung slope niya, which is the first derivative. Okay, so, yung Euler method kasi, sabihin natin, ano yung, what is the value of y, sabihin natin, yn when x equals to n. Ibig sabihin, somewhere here. Okay? So, ito. Kahit hindi na tayo mag-solve ng, di ba yung ginawa ko kanina, nag-solve ako, yung, sinolve ko to kanina, yung problem is dy dx, ito yung differential equation, plus 2x, diba? Na sinolve ko to, ordinary din, na-arrive ako dito, and then after that, nag-substitute na lang ako ng values. So, yung x, substitute mo, makuha mo yung y. Now, halimbawa, hindi mo alam to, okay? Hindi mo alam yan. So, magsosolve ka na lang using numerical. Hindi mo na isosolve siya ordinarily. Pero yung slope na lang, yung kung ano yung data sa yung derivative, yung differential equation, yun ang gagamitin mo. Hindi ka na mag-integrate. Ayun ang kaganda ng numerical kasi nga, with the use of computer, nagiging accurate yung solution. So, ganito yan. Yung next point, kasi ito yung first approximation ng kwan. Now, yung second approximation, halimbawa, meron tayong distance dito from this point, okay, hanggang dito. Tawagin natin itong h. Okay, so, ito na ngayon yung bagong point natin. So, dito na yung bagong point natin. Okay? Then, from here, gagawa ulit tayo ng another slope. Tapos, ma-approximate natin na naman yung kwan natin. Sabihin natin, ito yung h na rin ito. Di ba kanina tinuro ko paano pagkuha ng h? Diba ito yung v. Ito yung triangle. Okay? Ito yung vertical distance. Ito yung horizontal distance, which is h. Paano mo kinukuha yung v? V is equal to yung first derivative of xo o kaya yo times h. So, ganun lang siya. Horizontal distance times the derivative. Makuha mo na yung v. And ano yung value ng ito, yung xn ito, di ba? Xn, what is the value of yn? Yan. So, yn is equal to ito. Ano to? This is yo, yung original, yung kanina, dito. Okay? So, yo plus yung v. Ano yung v? Ito na. H times the first derivative of the function, you substitute yung xo, yung previous na value ng xo and yo. Makukuha mo na yung so ito yung ginagawa nating formula para makuha natin yung next point. Okay? So, yun yung yo. So, kung halimbawa, ano ba yan? Halimbawa, if we want to determine this value na naman, itong y na to, sabihin natin ito as y na lang. This y can be determined by adding itong distance na to, tawagin natin b1, okay, b1 plus yung kanina, ito, ano to? Ito na yung yn kanina, di ba? Ito yung yn, which is equal to yo plus b. Yo plus b. So, yung y1 natin ito, this is equal na to yn plus b1. Okay, and what is b1? This is equal to h times, kung kasi nag-drawing na tayo ng panibagong slope dito. So, ang gagamitin na natin yung yn saka xn. Paano? So, yung kung ano yung previous, kasi nga ito na yung bagong slope, bagong triangle na to. Ito na. So, bagong triangle kasi ito yung bagong slope natin. Yung kaninang slope natin, ito. So, from here, nag-jump tayo dito, then we draw another line. Kasi we are approximating yung although malayo sa drawing, pero pag maliit yung edge, halimbawa, edge is very small, halos magkadikit lang yung mga tangent lines sa original curve. So, na-approximate mo ng malapit yung value ng y. So, kahit saang x yan. Kasi nga, kung maliit lang itong h na to, kung halimbawa nandito lang yan, of course, yan. So, pag dinivide mo to from very small h na nagpatuloy ka ng paggawa ng tangent line, then halos nandito lang yung solution mo, yung numerical solution. Halos equivalent na sa original graph. Okay, so yan ang foundation ng Euler method. I hope you understand you. Solve tayo sa part 2 para mas maintindihan